Okay, welcome everyone. We have Dr. Volker Kraft with us here today again, and he's here to dish out a lot of knowledge and on jump and his amazing capabilities. Let's welcome Volker. Thank you, Volker, for joining us today again. Welcome.
Thank you, Olawale, and welcome everyone joining us to learn about predictive modeling in Jump. Are we ready to go, Olawale?
Yes, please. Yes.
Okay,
Uh,
fine. Thank you. So just the big picture again for everyone. This is the second session. We had a first online session introducing Jump and providing an overview. I think it was maybe 4 weeks ago or 5 weeks. So I'm not sure if everyone joining today already saw the first session and knows about Jump, or if there are people maybe new to Jump today. I also don't know if all of you have Jump Student Edition, the free version for academic use installed on a computer. So the basic idea was for, at least for this second session today, also to have some hands-on, some practical elements. So I don't know if you have Jump already installed. If not, I just shared the link where you can get the free license if you are academic, a student, a researcher, or faculty. You can get it from there. Um, and I really welcome everyone who has Jump available on the computer right now, also to get the data I shared with Olawala and probably also with you, which is the Jump journal you see on the left. It's called a Jump Start into Predictive Modeling. So this is one file, but a bundle of information and links to the internet and also resources and also some data we are going to use. So it's all packaged in a single file, which is called a journal in Jump. So it, but the point is you need Jump software to open this journal because it's a Jump file. Yeah, but if you have Jump installed, open it and then you're welcome to follow along. If you are new to Jump, if you don't have Jump installed yet, my recommendation would be maybe don't get distracted. Just watch the session today, and you will receive the journal and all the data, and you will be able to follow along and do the same analyses you will see today on your own later on. So I would suggest in this case, maybe um, take your time later and repeat some analyses in your own pace and setup. But I'm totally flexible. As I said, initially we thought about a really practical session today, but we can mix it. And I would like to ask you just guide me. Yeah, so if you have questions also using Jump at your end, let me know. Okay, so the second session today, that means that I won't tell you again what Jump is, but of course you will see um, Jump in action today, but you will see it being used for predictive modeling. So that's um, the application area, the topic today. Building predictive models using Jump. So I have two links here you could also click So one link takes you to an overview about the capabilities in Jump. So all the methods, or most of the methods which are implemented and you have in the standard software for predictive modeling. Yeah, and there are even further methods you can add to our software by installing add-ins, so-called add-ins, for instance, for deep learning and other purposes. And I will get to that later on. Let's start with the basics, what's already built in into the software and what's easy to use just by point and click without any scripting or programming today. You could, Jump has a scripting language, but we will take it easy today and look more at the concepts and how to organize and manage an analysis and a modeling task. Yeah, so there are some preparation steps, and also at the end, it takes some knowledge to make sense of the output and the results. And then the question is how to tell the story and how to document your findings. So we will cover the whole workflow more or less, except this. Yeah, so we won't look into data preparation, cleaning, or screening our predictors. Jump has a lot built in for these purposes. Yeah, also tools to clean up missing values or outliers and all these typical problems with messy data. We won't have messy data today. It's all clean already. Yeah, not real life, but we want to focus on the modeling steps. Yeah, so this is data related. There's a second preparation recommendation, and that's prepare yourself. And what does it mean? It means that we really recommend to start with exploring a new data set and visualizing the data and look at the data and see if you can make sense of some patterns or relationships or something you see. So that's a general suggestion. Before you start building a model, look at the data, explore the data. Yeah, and then you will move on better informed about your data set and hopefully about your problem when you enter the modeling step. And we will see this today. So we will see a bit of data exploration visualization just to give you an idea about what we mean here. And then the central step is building the model. Yeah? And building the model means that we want to build a model which generalizes. Yeah, it's not just about understanding and explaining a situation or a process. This is really to make predictions, yeah, to generalize on other data. Yeah, so that's the power of a predictive model. And for these type of models, we have to consider the enemy number one in predictive modeling. And this enemy is called overfitting. Yeah, and the good news is we can manage it. Yeah, and the management is done by a technique called validation. And Jump also has the tools to create a validation column and manage the validation. Most important, be aware of this enemy. Yeah, because what would happen? So here we see some data. Yeah, and the data is based on a systematic pattern, a signal, plus some noise. Yeah, and when we try or when we start to fit a model, a more and more complex model to our data, yeah, so the model gets closer and closer to our data points. But remember, the data points include the signal and the noise. And we should not model the noise, just the signal. That's the tricky part here. Yeah, and the the model, I can show you the model, it's the blue curve. Yeah, so this here is the underlying signal. Yeah, or it's called the true model, the underlying signal. Yeah, so this model would be perfect. We don't have this yet. We want to get there. Yeah, so we only have the data points, the black squares, which are our data points. And the message here is making the model more and more complex does not really help with prediction. Yeah, because if we get another data set, another sample from the same process, yeah, so still based on the same signal, just the noise is different. It's random, of course, it's noise. Yeah. So then a highly complex model would be worse on the new data set. So it would be worse for prediction for our task. And what we do is we create a validation set. Here you see that there are some data which are used for validation and some other data for training. And training means building the model. And the validation data is used to stop and pick a certain model with a certain complexity. Yeah, and by changing the model, building the model here on the training data, we look at the error on the validation data. Yeah, and then we pick the model which has the smallest validation error or the smallest error on the validation set. Yeah, that's the trick. And if you look at that error, we see that third order is probably doing the best job here. And that means this is the winner. Yeah? Don't improve the model on the training data because it will get worse on the validation data. And by that, on any new data you will get in the future. Yeah, so here's another overview. Yeah, so we see the root mean square error. Yeah, and the green curve is the training data. Yeah, and here the model gets more and more complex with higher order. So the training data, the model gets better and better. It seems so, but the story is different on the validation data set, the purple one. So there's a sweet spot. Yeah, and the sweet spot is here, and that's the third order model. Yeah, and the task will be to find this sweet spot. And to find this, we need two subsets, at least two subsets of our data. And I will show you how to do this and how to use them in model building. Then we will, yeah, build the model, maybe setting some specific model controls, and then we will get a model report at the end and hopefully some insight. Yeah. But we can take the model formula, and then also use that model and predict on new data we may receive in the future. Yeah. Predictive modeling, our main task today. And then the question is, because there are many ways, it's not just one modeling technique. You can have different complexity. There are also different ways to build um, that model. There are also different modeling methods. Yeah, so many ways, also in Jump, to build a predictive model, many options. The question is always, what is the most useful model? Yeah, and for that you have to do some evaluation and assess maybe different models, compare them. There's also a platform called model screening where you can do this in an automated way, checking many different models automatically, um, all to find the best model for your problem, for your data set. Yeah, without any programming. Yeah, so for some deep learning, Python will be used, which is embedded in Jump. But what we will see today is just um, drag and point and click. So that's the overview. Um, yeah, so we will basically skip the data prep part and directly jump into our example, the case, and then follow these steps here, but also building different models, several different models, and then we will compare them and we hope to find a useful model for our problem. So this is the the outline today. So we will look at our data set first, and the case here is um, a marketing related data set. So we have customer profiles, and for all the customers in our database, we know if they churned, so if they left our company or not. Yeah, and churn is the response. Yeah, and the task to build a predictive model on that data set is that later we can apply the model on any existing customers, and the model will tell us the most risky customers who may churn in the near future, who may cancel their contract. Does it help? Yeah, maybe marketing can send some special offers and hey, here are some good news. You can get a new mobile um, for a reduced price, or you can use some special services for free just to keep them happy. But we have to know who are these risky customers who may churn, who may leave us. So we will explore this data set first. So this is the part, prepare yourself. Yeah, so let's have a look at the data set. Then we will prepare for um, avoiding overfitting by validation. And then we will build several models. The first model is it's not a typical regression predictive model. It's a regression model, but because our response is categorical, yeah, churn or no churn, two categories, we will use a logistic regression model. And then we will also look at the decision tree. we will look at a model with many trees, a random forest, and a neural network. And then the question is, which of them is the best model? Yeah, which has the best performance for our task? And there are some optional topics we may look into just as a demo if we have some time at the end. So, do you have any questions about the roadmap today? What we want to do and why and what we need? If you have a question, please just type it into the chat. A question from my side, is there anyone also following along on on a personal computer? Um, so really practicing these steps. If yes, okay, at least one. Okay, cool. Thanks for letting me know. So I will take it a bit slower and make sure that you can also take at least the main steps on your own. And I'm always happy to hear if that works for you, or if not, let me know and I'm happy to help. Okay, we are ready to go. And this is the data set, by the way. It says churn data embedded. So that means that behind this simple button, I can open it and you see that there's a jump script. So here we have a jump data table embedded. And if we click on it, the data table opens. So just click on this churn data button. And then you should you should see this data set, this data table. It's a jump data table. Maybe arrange it so that you can maybe see the flow here on the left and also the data table. And then we will see some outputs in a minute. You can also move these borders up and down so that you can see everything you're interested in. It's not that much in this data set, so I think it's easy to arrange a view where we can see the important information. Okay, ready to go. First thing is let's explore this data set. And as you see in the top left area here, you see these green triangles, and they are all stored analysis scripts. So there's also a folder or a group of scripts here, exploratory analysis, with several scripts you can just run for exploratory analysis, just to see some sample outputs. Maybe just one I want to show you. We cannot do this step by step because it takes some intermediate steps to rearrange the data. And this is answering the question, what is the churn rate per state? A first question. Okay, to answer that, we have to have some basic understanding of our data set. So churn rate, what we know is if a customer churned or not churned. Yeah, for 4,118 customers. So that's also the number of rows in this data set. Yeah, records from a customer database. That's the response. Binary. Yeah. Are there more churn or no churn customers in this data set? To answer that, you can click on this little histogram and then you get a preview. And here we see that no churn are 2,147 and churn, that group is a bit smaller. So it's comparable. It's not a big difference, but we can see this just by looking at the previews here on the column headers. You can open them by clicking this little icon. And then we also have predictors, and predictors are the customer profiles. So we have a lot of information about each customer. So we have a number of average calls. I guess this is per month. We have the average calls on weekdays. We have the percentage increase month on month. So that's the revenue we earn from a customer, and that's the increase of the revenue, so the money spent. And as you see, the customers, these are probably telco customers. So we are maybe a mobile service provider. These are our customers, and there are monthly costs to pay. Customers have a different um, plan, account plan, and that can be silver or gold, as we see here. And that's a categorical variable. Also, the complaint code, that's the reason why they called the support the last time. What was their reason to complain about? Was it about billing, a problem with billing, with the call quality? Did they want to inform us about a new address because they are moving? So these are the categories of complaint types. Average days delinquent, that's another interesting variable. That's the number of days we are waiting for the money. So after sending out the invoice for a month, we didn't get the money yet. If there is a number of days maybe higher than zero, so then the invoice has been sent. But here we are waiting to 23, almost 24 days for the money. And some other information as well. And there's a state. And this is a telco provider in the US. So we have all the US states on the data set. Arizona and so on and so on. So back to the question. What about the churn rate by state? For that, you have to do some regrouping of our data table. And what can be used here are the table tools, and also a tabulate tool to calculate some summary statistics for certain groups, states in this case. I don't want to show you all the steps, just the result. And the result is this summary data table. You can click this by drag and drop. You can click this together. Here we have now the number of customers per state, and then the number of customers who churned. Yeah, and then we divide one by the other, and then we get the churn rate by state. Yeah, and to see the churn rate, we can use the state and put the state into mapping. We see the shape files for US states, and then the churn rate, which is a continuous variable on top. And I can change the gradient if I don't like two colors here, maybe just one color. So churn rate is higher if it's more red. Yeah, so for Florida, the churn rate is 62%. And for Idaho, the churn rate is just 32%. So this could be already and then I click done. So this could be a visualization you already use in a meeting, and then you can answer the questions if there are geographic differences among your customers. Okay, that's data exploration, of course, asking specific questions, exploring some patterns. So I just run the second example from the exploratory analysis. And this is a graph builder output. Yeah. If you ask how difficult is it to get such a diagram? So now we see the number of customers per account plan, gold and silver, and then who churned, the red, or no churned, the green. Yeah, and we see the differences. So how to get such a visualization? It's Graph Builder again. Yeah, so we have the account plan subtype on the x-axis. Yeah, account plan subtype, it's this variable. Drag and drop on the x-axis. So these are all the gold customers, and these are all our silver customers. I change from data points to bar chart. Now we have the overall counts, gold versus silver. And I want to break it down by churn. Yeah, and that's the target churn, our response variable. I could have it here or here, yeah, or I can overlay. And overlay means show both of them in the same graph. It's this one, and then the style is different. So what's used on the left is a nested bar chart. And then you click done, and you're done. So it's that easy. And there are hundreds of other visualizations you could create very easily and explore a data set. Another one, also using Graph Builder, is a parallel plot. And here we have the gold and the silver customers again. We have some of our predictors down here. And then you can also select some customers or customer groups and look for patterns and see how they relate to other information in your data set. We have no churn and churn by color, and I can also filter by complaint code, and then we just see the customers who complained using that reason, moving or the moving customers in this case. And we see a lot of green. So that means The ones who called us because they are moving, these are not the typical ones who are going to leave us. Distribution, that's another one. You can just open from running the script again, and this is the report. So that's maybe suggested if you are using this for the first time. Just to give you an idea again, how to get to this output. So this is a univariate analysis looking at distributions of for many variables. Yeah, so analyze distribution, I launch this analysis and I want to look at target churn and all the predictors. But I select this option here, histograms only. Yeah, so no statistics and standard deviations and all of that, no summary statistics, just the histograms. And I click OK. Then we get this. As we see in the other one, we also have box plots here. I can add them, yeah, by opening a red triangle. And before I do this, I press the command on the Mac or on Windows, the control key. So I press a special key, typically left of your space bar. One key, and then on the red triangle under display, no, here, outlier box plot. That's the option. Yeah, I add this, and then because I pressed the key, it's done for all the variables where this can be applied automatically. Yeah, and these are all the continuous variables. And then the final step would be to arrange this, maybe having 5 distributions per row, and then we have the same output as the script generated. And then we can look at the distributions of our variables. So we have churn and no churn as a bar chart. And then we have histograms, another bar chart here, silver and gold, another bar chart here. This is a histogram again because it's continuous data. And there we also see some extremely high data points. This one, for instance, average number of calls. So there's one with almost 200,000 calls. So maybe that's a bot or a call center or a special customer at least. Yeah, maybe we want to exclude this one from our model. And then I select it. Yeah, I select this data point here and right click, and then I can hide it and exclude it, and then it would not be used for modeling. I don't do this right now. I keep all the data, but that's part of the exploratory analysis. Think about what you see. Think about if you want to keep all the data or if you need some cleanup. And then I click on churn. Yeah, and with that, we see all the customers who churned. So these are the bad ones from our perspective. You know, all the ones who left us. And now we can look at the predictors if we see some interesting patterns there. Average days delinquent, a continuous predictor. Yeah, look at this. What is it telling you? Yeah, it tells us that if we are waiting for the money for more and more days, so if this variable increases, then the likelihood that that customer will churn increases as well. Yeah, because the portion here of churn customers gets higher and higher when that number of days gets higher. So that's a continuous variable. Maybe a categorical one, this one here. What do we see here? Ah, moving again. Yeah, so that was very green on the graph we looked at. And we also see that we don't have a lot of churn data in that category. But look at call quality. And here for call quality, 720 of 904 customers churned. Yeah, they all had a problem with call quality. And in that group, the portion of churning or the probability to churn was quite high. I hope you got the idea of using a very basic analysis platform just to explore your data set and to make sense of your data and create some hypotheses and also check the quality and everything in your data set before you build a model. So that's the first step. And let me close that one. Now, validation. Yeah, so that's for controlling overfitting. Yeah, so we don't want to overfit our model. We want to build a model which works best on new data because we want to use the model for prediction later on. Yeah, and what you could do is analyze and then under predictive modeling, there's a tool called make validation column. We don't need to do this right now because we have the column already in our data table. But I want to show you where you would start if you don't have this validation column yet. It's make validation column. I don't have any optional settings here. I just click OK. Yeah, and then you set the proportions here. So you could say, okay, training set 60% and then use 20% of our data for validation and just another 20% for testing. So training is build the model. Validation is select the best model. And then test data won't be used at all. So this would be the perfect data to compare multiple models later on. That's the most honest assessment of models because the test data have not been seen by the model before. You could also, if you don't have that much data available, you can also just have a training and a validation set, just one split, also fine. Luxury, a bit of luxury is also have a third. subset. Yeah, and this sets if the split would be static or fixed, or if it would be a formula, and then the assignment would be done every time again randomly. Yeah, you can also set a random seed if you want to do it in the same way each time, or leave it open and then it will be totally random and a new assignment, a new split every time you build a new model. We have this here, subset. That's our validation column. Yeah, and we have training data, validation, and test. So we have three subsets, the luxury case, yeah, and we can check the distribution again. So this is our response, and that's the split. And here we can see that we have 20% for testing, 20% validation, and 60% training. And looking at our response data, it's a balanced distribution over both categories, churn and no churn. What's nice. So we are all set for building a first model using validation. Yeah, using validation, we will just use a validation column, the split we have defined by that column. Yeah, so there are also other techniques like k-fold, cross-validation, or keeping a portion of your data you can specify for validation. So there are also other techniques. This is maybe the most flexible and best technique if you have Jump Pro or the Jump Student Edition available. Any question so far? So we had a look at the data set. We prepared for validation so we could move on and look at a first model. Any question? I don't see any. Yeah, so today I think everything is basically happening on the analyze menu. Yeah, last time we talked about univariate, bivariate, and multivariate methods. And I also mentioned fit model. So that's a modeling platform for building linear models. And then we have a section for predictive models. So here you find neural networks, decision trees, a forest, machine learning methods, and assessment tools, and this one make validation column. There are also some other specialized models we won't touch today, including functional data or nonlinear models, curve fitting, Gaussian process, and so on. So today we will build one model using fit model, that's linear modeling regression. And then we will also build three predictive models or models from the predictive modeling menu. And that will be a decision tree, a bootstrap forest, and a neural network. First thing, fit model. What I suggest to keep it simple is let's start from the result and run the modeling platform by executing this script, and then we will take it from there and also see how this was started. So this is the model using fit model. I just click the green triangle, and this is the model report. So there's a lot of information here, a lot of numbers actually. Um, Maybe back to the question, how did we get to this analysis, this model report? You can also find it out yourself by opening the top menu on the red triangle and then go down, look at redo, and then relaunch this analysis. Yeah, and then it goes back to step one. Yeah, and as you see, this is fit model. Yeah, so analyze fit model. Yeah, this is the launch window, but empty. That's a green field, nothing configured yet. This is the fit model configured for this analysis. Yeah. So here we see the response has been set. That's our Y, the response, the outcome, target churn. Yeah, we have just four predictor variables added to the model as a main effect, or four main effects in this case. How do you know? Yeah, maybe um, just by exploratory analysis, or you have some marketing expertise, subject matter knowledge, and or you are on the job for a long time, so you already know this, or you just want to test because these are maybe the most plausible, most promising predictor variables, or that's a bit cheating. You went to screening, predictor screening. Yeah, and here you could just ask, okay, for this response, using all the predictors, give me a ranking. Yeah, and then you could also maybe just take the top four from here. So it's not exactly the same list. So it's not the way how this was done, but it's an alternative to screen the most important axis or predictor variables. And because target churn, our response is categorical. Remember, two values, churn or no churn. The personality automatically switches to a nominal logistic regression analysis. So that's happening automatically just by setting the variables. Yeah, and then you click run, and then you get to this or similar output. Yeah, here's the overview, the main result, average days delinquent. What we already saw in the distribution analysis, you remember? So the number of days we are waiting for the money. We saw that the more days, the more likely that person will churn. Yeah, and this is confirmed by this model. Also, complaint code. We also saw a pattern, you remember? So, call quality, yes. Moving, probably not. Yeah. Also, the percentage increase of the monthly revenue, and also the average number of calls on weekdays. They are all significant. Yeah, and the whole model is significant. Yeah, so much better than just guessing the average. And this is interesting because looking at the model performance, yeah, we see the performance on all subsets. And that means we see how good the model performs on the training data, on the validation data, and finally on the test data. Yeah, so remember, the test data was not used for model building or model selection. It's just for assessment. Yeah, and because this is a categorical response, so we are doing a classification task, and that means we can misclassify. We can do errors. Yeah, we can say this customer churns and he or she didn't, or vice versa. Yeah, a misclassification. And using this model we have here, yeah, if we would use that model, we could expect a misclassification rate around 20%. The good news is almost 80% the model would be correct, predicting churn or no churn. So still numbers, and statistics, the parameter estimates, the model. So you can also have even more statistics. But what you typically use to understand what's going on and to interpret a model in JUMP is something called the profiler. Yeah, and the profiler is the second thing I want to point out here. Um, and if you don't see the profiler on your model report, it is there. You just need to show it, and you find it on the on the red triangle, and it's called profiler. And here you go. So this is the categorical profiler. Yeah, so we see the two probabilities. Yeah, it's a nominal logistic regression. So before saying no churn or churn, before making that decision, internally, the model will determine two probabilities, one for each category. And here we see them, and they sum up to 100%, of course. Yeah, it can be just one or the other case. And down here we have our four predictors with current settings in red color. Yeah, and now the interesting thing is you can ask, what if? What if the number of average days delinquent, so this number here, if this number goes up, yeah, we already see what we can expect. Yeah, but we can use the profiler and change it. Yeah, and JUMP uses the model to update these probabilities. Yeah, so the likelihood to churn gets higher and higher and higher. And if we approach 50 days, or 60 days, maybe 2 months, it's almost 100%. So that means more or less forget about that customer. So he or she is already decided to go. Yeah. So that probability is around 99%. Yeah. And if you set this to a very, very small number, yeah, even if they pay immediately, there's a remaining probability to churn, but it will be much lower. Yeah, and these are just the customers who complained about a billing problem. Yeah, if we look at another group, the customers who complained about the call quality, then this probability more than doubles. Yeah, so from 17% for billing problems to 38% for call quality problems. And as we saw, moving it seems to be less critical. So then the remaining churn risk is around 7%. And if the number of calls on weekdays gets higher and higher and higher, you see that the probability to churn gets lower and lower. What makes sense? If they are using our telco services more, they are less likely to churn. So, just to summarize, a first model, this is a regression model, logistic regression. Performance is shown per subset. Yeah, and what you typically do is go straight to the test data, yeah, because that's the best assessment you can do. You have a lot of statistics, but look for the profiler, which is an interactive visualization of your model. Okay, if you want to use the model, if you want to deploy this model, then it's a different story. So then we need the model somehow to deploy and implement it. How can we do this? Ba-dum. So yeah, I just show you the way what you typically do from any model. What you could do is save the probability formula. Yeah, and saving the probability formula will save at, for instance, the two formulas calculating no churn and churn probabilities as a formula. Yeah, and here you see that this was already done. And these are the two formulas calculating the probability for churn. And that's the formula. And there's an embedded formula, which is this one here. Yeah, and this is calculated based on the customer information, our predictors. Yeah, so you can see the formula. Typically, you don't need to worry about it because you just look at the profiler. You just look at the profiler, but deployment, that's a different story. Any question about this first model? So if you want to try this out for yourself if you don't have it available, if you don't have the software available or the data available right now, or if you watch the recording, get access to this jump journal, open the data set you have here. Yeah, and then you can just look at the stored analyses by running them again using the green triangles, or start on your own picking an analysis method. And you can try any other method, of course, you are interested in. Okay, let us add a second model. And this is a decision tree model um, for classification. Classification, again, because our response is categorical, we have to classify our customers, um, our data points. And for that, we want to use a single tree. Yeah, and the platform for this is called partition. Yeah. And if you have an understanding about decision trees, it's a nice model because you can see a lot, you can understand it, you can interpret the model quite easily. So it's really nice and also good for exploration. It's maybe not the best model for prediction finally, but it's a good exploratory tool. If you want to use it, the options you have are, for instance, the learning library. So going back here, so I have all the resources and everything also mentioned in the journal. You can just open this and you find the links. Yeah, and for instance, the learning library. And the learning library has one-page guides and short tutorials. And there's one section called Data Mining Predictive Modeling. Yeah, and then you take this one, a classification tree. That's what we want to build. Yeah, and then you get a short video, maybe 2 minutes, and um, a single document. Yeah, which is this document here. Yeah, so what is it? How to build a classification tree in JUMP using some sample built-in sample data, how to interpret the results, and some notes where you can learn more. A single page, that's it, just to get you started as an example. Yeah, if you already know how it works, but you forgot about where to find it in JUMP, so you can start here. So we are looking for the partition platform. There, predictive modeling partition. Yeah, and then you will be pointed to that platform under Analyze, Predictive Modeling, Partition. And that's the launch dialog. So that's how you start. Yeah, and then we add the response. It's the same procedure for any other model. As again, set the response, set the predictors access, and make sure we are validating and use different subsets, and then okay. So this is the starting point to grow a tree, a tree-based model. And we see all the churn data, the red ones, and all the green, the no churn customers in two buckets. Yeah, so the locations they are jittered a bit to make them visible. And we have the split into training, validation, and test. And now, by splitting, the question is, what is the single predictor which splits our data into two groups, which are as different as possible regarding the difference between churn and no churn? Yeah, so a first split has been done just by clicking split. Yeah, one splits, and that's the one. And average days delinquent does the best job to get as much as red as possible on the left side and green, as much as green as possible on the right-hand side. We cannot sort the data in a better way just using a single predictor. Yeah, so the statistics are the G square and the log worth. And you also see, so this is a transformed p-value, and this is a chi-square statistic. Um, I can add some more information to the tree. So now we see that on the right-hand side, these are all the customers with a small average days delinquent, more green. And this is with a higher average days delinquent above 12.7, we see more red. So we already learned this, that average days delinquent has an effect on our response. And by doing this, we expect to see 74%, or let's say 25% churning on the right-hand side compared to 74% churn probability on the left-hand side. And then we split and split and split, and the tree grows top down. It's a very special tree. It grows top down, and the buckets become more pure as we move on with splitting. Yeah, so this is very red here, and this is very green. And to get to the green one, you just need to follow the splits. Yeah, easy to understand. And now what's happening here? Go uses the validation subset to select the best model. The best model is the decision tree with the best number of splits. And let me go, but that's the result. So we have 18 splits finally. Yeah, we could even move on and split and split and split and make it more complex, as you see here. And that would be the training data. And we see the R squared on the training data, and the R squared goes up and up and up and up with more splits. But the validation R squared, the red curve, goes up, and then after 18 splits, it goes down again. Yeah, it doesn't improve anymore. So there's no reason to make the model more complex than 18 splits, especially if you want to use the model on new data for prediction. And again, a lot of diagnostics and more information on the red triangle menu. For instance, the details. So that's the performance. And again, we have the test data and the misclassification rate for this model is 20%. Yeah, not bad. You see the confusion matrix. So the different types of errors done. These are the good ones. And then this is one error and this is the other error. Other diagnostics like receiving operator characteristic curves. So here the area under the curve is important and the higher the better. And this is shown visually, but also as a statistic you want to maximize. That's a typical diagnostic for classification models. And a lot, and yeah, much more you could look at. Same final steps. You could also look at a profiler, and you can also save the prediction formula, the model, to the data table. Yeah, and this was also done. Yeah, so it's this group of columns which are in this data table. And here we see the formula for the decision tree. You don't want to read it, no worries. Just showing you that it's a formula, it's there, yeah, but you don't want to read it. Okay, one more. If there is no question about the decision tree. Decision tree, a nice modeling option also to explore your data. It's an exploratory model. Yeah, because you can see a lot. You have the tree. You have a rule set how to split your data to get into one or the other way direction. Yeah. Can we do better? Yeah, typically one way to improve the model or get a better model for predictive tasks is to build many trees. And many really means many, typically 100 or hundreds of trees. And this is called, in statistics, it's called a random forest. A forest, many trees. In jump, because a random forest is a protected um, term. There are some patterns around it. We are just naming this bootstrap forest, but it's actually the same technique. A bootstrap forest, analyze, predictive modeling, bootstrap forest. That's where you would start. We have this available also as a script, so we can just run it from here. And again, a lot of numbers and metrics. And the first number I would look at is maybe for comparison, the misclassification rate but for the test subset, 18%, a bit more. Yeah? So that's not bad. It's slightly better than single tree. It's also better than the regression model. Yeah? All the details down here. And how was this started? Yeah, so re-engineering, relaunch this analysis. So here you see how this was set up. The launch dialog, that's the bootstrap first platform, the response, the factors, validation, all the same, and then bootstrap first. We click OK because you don't get to the model immediately. There's a control window where you have several options you can set. And one of them is, of course, the size of the forest. How many trees do you want to build? Yeah, and then you see that there's some sampling and bootstrapping. So there are random selections of subsets of predictors and also random selections of um, the customers in this case, the rows. And this is the random selection is done using bootstrapping. So every tree will be different. Yeah? And then you will have many, many different trees and then average and get the final model. Yeah, and then click OK. There are some best practices. The first best practice is keep the defaults because Jump has a lot of intelligence built in to come up with some reasonable defaults for your problem. Yeah, so if you don't know better, just keep them and then maybe start to play with some of them. Yeah, you can also use a tuning table where you systematically tune these parameters to find maybe an even better bootstrap first model. Yeah, and then you get to this one, the output. Um, there's a profiler again. Yeah, so we have not just four predictors. Here we have all of the predictors. Yeah, and then average days delinquent. Where is it? Average days. Ah, here. Yeah, so don't be confused now. Now it can be configured, of course. Now we have churn on top and no churn below. So this is just mirrored, but the conclusion will be the same. Yeah, and you see some ripples here. So this is really a nonlinear model, nonlinear behavior you can see here. And it even goes down to all the individual states of the US. And as always, save the prediction formula from this model. Yeah, and then some more prediction formulas calculating the probabilities using a bootstrap forest model. And the final model, we could keep going and add another model and do some fine tuning and um, so really be creative and try many models or use model screening. We will see or at least mention. later. But the final model here is a neural network. And this also lives under predictive modeling, neural. And then you start this pretty much the same response as always, response and factors and validation. And then click OK. And then another control window. It's not, the model is not fit yet. So we have to specify first layer, type of activation functions, second layer. If you want to use some boosting, so self-learning or not, some other options we have down here, and then you click Go, and you get a first neural network model. I just run it from the script again. So this is one model, and a bit disappointing. Das habe ich nicht verstanden. Oops. A bit disappointing is that if you look at the misclassification rate for the test data, we see almost 26%. So if you expect it to outperform the bootstrap forest, it didn't happen. So it's not better than that one. So that's the neural network model. And here you see again the controls, and you can also try another model. So if we add some, if we add some boosting, so we have 10 boosted models in a row, and then we are building the next model based on the residual of the previous model, to implement some self-learning. We can just try that one. Well, so now we have this first one, and now we have a second one. And we see that misclassification rate, slightly better, but not the winner overall. So it's quite easy to try other variations of a neural network by changing the controls, build another one, and you can compare them. And finally, you pick the model you want to use and then save the formulas, prediction formulas. And again, also for that one, we have the formula saved in our data table. And with all the models saved so far, so all 4 models have been saved. Their prediction formulas have been saved to the data table. So that means that we can run a model comparison. That's a tool which also lives under predictive modeling. So here you see model comparison. And that could be used to compare and to assess all the different models we have so far. That's one option. So here we have the measures of fit, some performance metrics here, and I can sort by misclassification rate. Oh, 13%. That would be nice, but this is the whole data set. Remember, for an honest assessment, we only want to look at the test data. So one way to do this is adding a filter. So on the red triangle. So for all the jump platforms, go to the high level menu and look for a local data filter. This adds a data filter to this report. And we want to filter on the subset. So I double click subset. And now I select test. And here you see that now we are just looking at the 20% test data. Yeah, so these data were not used for training and not used for model selection, just for testing. So that's nice. And the winner is, following this model is a comparison bootstrap forest, yeah, with a misclassification rate of 20%. One comment, if you build a bootstrap forest model again and again and again, you will get different, slightly different results because there's some randomness in model building. Yeah, so there's a bootstrapping, which is random on your rows. There's a subsetting on the predictors, which is random. So you may end up with slightly different models, but overall, especially for high number of trees, it should be comparable. So that's the winner model. Is it the same for validation data? Yeah, yeah, same for, even the same order for validation data. That's the end of that story, building predictive models, comparing them, and um, yeah, selecting the best performing, hopefully the most useful model for our problem. Okay, I just want to mention three options which are really, really helpful as well and useful for predictive modeling. So you should know about them and you can learn about them in more detail also on your own, or we can arrange another session if you like. Um, before we can discuss your questions or comments. Um, just maybe a few minutes, 8 minutes. The first thing is the formula depot. What does it mean? It means that you can, so if you have a model like this one, yeah, so and for all models, what we did so far is saving the prediction formula out to the data table. Yeah, that's one option for later deployment. Another option also for assessment and keeping several models in one place is to publish the prediction formula, and that would be sent to a so-called formula depot. Yeah, and doing this for all our models would create a formula depot which looks like this. So we have a first model, nominal logistic. We have the partition tree, some information how the models were built. We have the bootstrap forest, and we have the neural network model, and then we have the some more information we could use. So from here we could have an overall profiler like this one, and I can change one customer setting, and then you see how this changes the predicted churn rate. or churn probability. And you also see that there are also differences between the models. So they are not giving the same results. So maybe such a comparison could be also um, a validation against your experience and knowledge to find the most useful model, maybe which is best in line with your understanding. Yeah, so that's an overall profiler. You have the detailed model comparison, all the metrics for all the subsets, three subsets, four different modeling types. And all of that is available by model comparison and the overall profiler, the big picture, for all the models which have been added to this depot. And last but not least, what you can do from here, if you want to take the bootstrap forest model because you think that's the one you want to deploy, you can get the scoring code in a different language. For instance, the Python code for the bootstrap forest model. Yeah, and this is the bootstrap forest in Python. You can just export and deploy, and also in other languages. That's the Formula Depot. One thing for overall profiling, model comparison, and exporting the model in a different programming language. The second is model screening. Yeah, and model screening is an automated or half automated way to try many models. Yeah, how does this work? I started from here again. So you see model screening. Now Jump is looking into many different models, all of these, and then we can just jump to the test data, and there we have a ranking. So if we look again at a misclassification rate, yeah, so we see the best model is still the bootstrap forest. Yeah, but Jump also tested a support vector machine and neural boosted model, k nearest neighbors. And this is started under predictive modeling model screening. It is just checking or testing many models, many modeling methods. And this starts like this. So you specify your problem again. That's same procedure, what we already saw. And then you select all the modeling techniques you want to try. Yeah, you can also have higher order effects or some other validation techniques. And then you click OK, and then Jump will build all these models and returns a comparison of all these models. And then you can say, OK, this is an interesting one. You can select it and then run it from here. That's model screening. It just automates what we did manually, building one model, another model, another model, another model, always saving the um, formulas and then loading them into a comparison platform. So this is all in one step, called model screening. And finally, torch deep learning. So this is an extended capability which needs to add a jump extension called an add-in. You can find on the marketplace, and the two add-ins which are mentioned here, they are all for free. One is XGBoost, so extreme gradient boosting models, and then torch deep learning using PyTorch package and out of jump. So doing this, I open this data set because this can be used also for other data, not just tabular data, but also image data or functional data. Um, yeah, and here we have images, more than 7,000 images of this metal product, and you see some scrubs and distortions somewhere. And they are also classified. It's the same task, classification into two categories. One is a defect, and the other one is okay. We also have validation. So two subsets for validating. And what you would do after installing the add-in, under add-ins, you will see Torch Deep Learning, a menu, and then you start Torch Deep Learning. I run the script. So this is what you would see. Again, you specify the problem. The image is the input, and the classifier is the output, and validation by that column. And then you get to this report. So this was using image data. You see the predictor was an image. We have two classes as a response, and then the model set up 20 epochs and so on. We see the image model, which was used. You can also switch to other models or even add more models and download them. And there are also some advanced settings and hyperparameters you can modify if you want to. And then you click go. After changing this, you click go, and then you build another model. And here we see validation accuracy 98%, validation R squared 92%. So not bad. And again, everything is interactive, and you can select some data if you want to deep dive and look into a subset of your data. That's called, a Torch Deep Learning add-in. This uses Python, which comes with Jump as an embedded component under the hood, and just installing the add-in will also get all the packages and everything you need to run this. Just one example that you can do much more in Jump, especially with Python and other integration options than the built-in modeling tools, which are already powerful and a huge bandwidth of different modeling techniques, especially in Jump Pro. Jump Pro has many more options for machine learning and predictive modeling, but the good news is Jump Student Edition is basically Jump Pro. So you have all the options available for free. And that's maybe the end of the show today. Everything I wanted to share, I wanted to show you. Um, as I said, you will get this file, and because this image data set is a very large data set, it's not embedded. This is just a file reference. So I can also send you this data table with the images if you want to try this out. So you will get two files. You will get this journal, which has the churn data built in as an embedded data set. And if you want to try Torch Deep Learning, you also get the image data. And then you open it and you just run the analysis to see an example. And if you want to learn more, there are many options, and you find predictive modeling in many places. So these are the capabilities. The learning library I showed you already, just getting started. But there's the statistics knowledge portal. If you really want to take it easy, that is a very simple, easy to understand explanation of the basic concepts in predictive modeling. If you want to invest some more time and really learn about predictive modeling in an e-learning course, this is the STIPS um, program, Statistical Thinking for Industrial Problem Solving. Yeah, and there's one module called Predictive Modeling and Text Mining. And these are the topics covered in that module. Yeah, and you see it needs maybe 3 to 4 hours to work through all the examples, and yeah, quite nice and engaging. That's maybe a deep dive into predictive modeling. We have webinars which are also addressing modeling, predictive modeling, mixed models, many ways to build models, more resources you can just browse. And the help, the documentation, just jump.com/help. And then there's a book on its own about predictive and specialized modeling. And there you see all the methods, and then they are documented, and you find examples in detail with all the options, everything explained and documented. Okay, are you still there? It seems everyone is muted. Um,
Thanks a lot, Volker.
Hello, Ale. Good to hear you. Yeah,
Thanks so much. Wow, this is a lot. Mhm.
it is. Yeah,
Yeah,
yeah. I hope not too much or too overwhelming. Just start somewhere, and we, we
yeah,
we we just used four different models today, but
Yeah.
you saw how it works. And with that, you can also use any other modeling technique. It's basically all the same.
Yeah.
Setting the problem, building the model, look at the results, look at the profiler, save the formulas, same process. Um, and then you have the overall tools allowing you to compare the models, making an assessment or exporting Python code or anything.
Yeah. Well appreciated. Thanks, Volker.
You're welcome. Is there any question?
Question? Let's have questions.
Did
Any
you see
questions?
any question?
Okay.